All right, welcome. Today we're going to tackle a question that pops up, well, just about everywhere. How do you actually compare two different groups? But instead of a dry textbook lecture, we're going to think of this as opening up a statistical toolkit, a set of practical tools you can actually use to get clear answers from your data. So let's make this real. Imagine you're running two different ad campaigns. You look at the numbers and ad A, it seems to be doing better than ad B. But is that difference really real? Or is it just, random chance, a bit of luck? How can you know for sure where to put your money? Well, this is exactly where statistics comes in. It gives us the power to cut through all that noise and find a real answer. First up, we're talking about comparing proportions. And really, all that means is we're comparing two percentages. Think click-through rates, conversion rates, that kind of thing. Okay, so before we can start using our awesome new tools, we gotta lay a little groundwork. Just a couple of key ideas we need to get straight so we know we're doing this the right way. First things first, we have to know what kind of data we're dealing with. So in our ad example, right, we're showing the ads to two totally separate, unrelated groups of people. That's what we call independent samples. Now, the other option is dependent samples. That's when the data points are connected somehow, like if you measured the same person's blood pressure before and after a treatment. For everything we're going to do today, we're focusing on those independent groups. Now, this next concept, it's kind of like a special ingredient we're going to need for one of our tools. It's called the pooled estimate. Just think of it like this. If, and that's a big if, we start out by assuming our two groups are basically the same, then it makes sense that we can just combine or pool all their data together. Doing that gives us a much stronger, more accurate estimate of the single proportion we think they both share. Just hang on to that idea. It's going to be super important in a minute. All right, tool time. Let's grab the first big one from our toolkit, the hypothesis test. I like to call this the yes or no tool, because it's designed to give us one single, clear-cut answer. This tool just gets straight to the point. It asks one very specific, very important question. Is the difference we're seeing in our samples big enough to count as real evidence? Is it statistically significant, or could it just be a fluke? And here's how it works. It's basically a courtroom drama for your data. First, you've got the null hypothesis. That's the defendant pleading innocent, saying, nope, nothing's going on here, the two groups are the same. Then you have the alternative hypothesis, which is the prosecution, arguing, hold on, something is different here. Our job as the statistician is to look at the evidence and decide if there's enough proof to reject that claim of innocence. Okay, let's plug in some actual numbers to see how this plays out. So in sample 1, we had 45 successes out of 200 people, which gives us a proportion of 22.5%. Sample 2 had 30 successes out of 180, which is about 16.7%. So yeah, we can clearly see a difference, but the question remains, is it a significant difference? So we take all that data, and remember that pooled estimate we talked about? We plug it all into our formula for the test statistic, we turn the crank, and out pops this one number, 1.4265. This is our z-statistic. Think of it as a single score that summarizes the entire story of the difference between our groups. So, what do we do with this number? Well, we have to compare it to a critical value, which is basically a threshold for what counts as surprising. For standard test, that threshold is 1.96. If our number was bigger than 1.96 or smaller than negative 1.96, it would land in what we call the rejection region. But our number, 1.4265, it falls right in the middle, in the safe zone. And that leads us to our formal conclusion. So what does that mean in plain English? It means the difference we saw in our sample just wasn't big enough. It wasn't surprising enough to make us reject that innocence claim. Our yes or no tool is giving us a clear no. We did not find a significant difference. But hey, yes or no isn't the only question we might want to ask, right? Sometimes we need to know, okay, but if there is a difference, how big is it? And for that, we need to pull out our second tool, the confidence interval. So the confidence interval has a totally different job. Instead of giving us a simple verdict, it gives us an estimate. It creates a whole range of believable values for what the true difference between the two big populations might be. It's less about a final decision and more about estimation. It all starts with the simple difference we saw in our samples. Remember? It was about 5.8 percentage points. That's our single best guess, what we call our point estimate for the real difference out there in the world. But of course, one guess is never enough, so our formula then builds a margin of error, kind of a buffer, around that guess. And that gives us our final range. We can now be 95% confident that the true difference is somewhere between -2.1% and positive 13.8%. And now for the most important part of reading this thing. Look closely at that range. Do you see it? The number 0 is inside our interval. Since a 0 difference is a perfectly plausible value in our range, we just can't be sure there's any real difference at all. It's totally possible, statistically speaking, that the two groups are actually the same. And isn't that cool? Our yes-no hypothesis test told us we couldn't find a difference, and our how big confidence interval showed us that a difference of 0 was a real possibility. They're two different tools asking two totally different questions, but in the end, they point to the exact same conclusion. They work together. Now, any good toolkit comes with a user manual, right? So let's quickly go over a couple of common mistakes to make sure you're using these tools like an absolute pro. Okay, two huge things to watch out for. First, that pooled estimate we talked about, that's a very specialized piece of equipment. You only use it for hypothesis tests. Never, ever use it when you're building a confidence interval. And second, always double check if your samples are independent or dependent. Using the wrong test is like trying to use a screwdriver on a nail. It's just not going to work and you're going to get the wrong answer. So let's wrap this up. Today, you've officially added two incredibly powerful tools to your statistical toolkit. You have the hypothesis test, which gives you that clear yes or no about whether a difference is real, and you have the confidence interval, which helps you estimate just how big that difference might be. And that's really what this is all about. This isn't just memorizing formulas. It's about having the power to see through all the random noise in the world and find real, meaningful signal in the data. So now you have the toolkit. The only question left is, what important questions are you going to answer?